Any one of the two?
So I'm recording to the computer now.
Okay. So we can start the program now.
Patni man.
Namaskar, a very good morning to you all. Honorable Chief Guest, Dr.G Madhavan Nair, esteemed guests and fellow enthusiasts of science and technology. A very good morning to you once again. Exploration knows no bounds, and the pursuit of knowledge is a journey without end. In the vastness of the cosmos, we find the inspiration to reach beyond our limits. It is indeed a privilege to be before you this morning with the initiative spearheaded by SIF, Science India Forum, that brings attention to the Chandrayan mission, admirably championed by Dr.G Madhavan Nair, the former ISRO chief. Every program begins with a formal welcome, and Ms. Smita Ramesh, the most fitting choice, will extend a warm welcome to our esteemed chief guest, Dr. Madhavan Nair. Her presence adds a touch of grace and significance to this honor, making her the ideal person for the occasion. Ms. Smita.
Thank you so much. Hello, everybody. It is not often that one shares the stage with a Padma Bhushan and a Padma Vibhushan awardee. It is an absolute privilege to have ex-chairman of ISRO, Dr. G Madhavan Nair, with us today. Dr. Madhavan started his career in the Tumba Equatorial Rocket Launching Station in 1967. He rose to the position of director, Vikram Sarabhai Space Center, and finally to the position of chairman ISRO in 2003. During this tenure of 6 years as chairman ISRO, 25 successful missions were accomplished. As chairman Space Commission, Dr. Madhavan has been responsible for chalking out the future plan for space research in the country. His main focus has always been to achieve self-reliance in high technology areas and to bring the benefits of space technology to India's development, especially targeting the needs of the rural and poor sections of society. In the international arena, Dr. Madhavan has led the Indian delegations for bilateral cooperation and negotiations with many space agencies and countries like Russia, Brazil, Israel, etc. He has also been instrumental in working out mutually benefit international cooperative agreements. Dr. Madhavan has led the Indian delegation to the S&E Subcommittee of United Nations Committee on Peaceful Uses of Outer Space. Dr. Madhavan was conferred doctoral degrees by several universities and reputed institutions in India and abroad. He is a fellow of the Indian National Academy of Engineering, Astronautical Society of India, National Academy of India, Indian Society for Non-Destructive Testing, Aeronautical Society of India, and member of the System Society of India. He has been honored with the Padma Bhushan in 1998 and Padma Vibhushan in 2009. Dr. Madhavan Nair has several other awards and honors to his credit. It is my privilege and honor to welcome Dr. G Madhavan Nair on this stage. A very hearty welcome to you, sir.
Thank you, Smita. Now I would like to shed some light on SIF, Science India Forum, and its remarkable accomplishments. In 2015, individuals with shared interests got together with a vision to promote scientific temperament and nurture the immense talent among the students of the Indian community in the Kingdom of Saudi Arabia. Today, As we look back, we can proudly say that Science India Forum has not only realized this vision, but has transcended boundaries. Our reach has extended far beyond the central region, spanning across the entire kingdom. For our expatriate Indian students, Science India Forum has become synonymous with the science-based talent activities. We owe a heartfelt gratitude to the Embassy of India for their unwavering support over the years. Their endorsement has been instrumental in our journey. One of our flagship programs, the SPC, Shastra Pratibha Contest. This fosters young minds' curiosity about ancient scientists, igniting a passion for research. Winners enjoy educational trips to prominent Indian R&D centers. This year, in the month of August, they were taken to DRDO, HAL, and IISC museums in Bangalore, enhancing their knowledge. Among our cornerstone programs, the National Children's Science Congress. This stands as a testament to their remarkable potential within our young minds. The projects submitted by these students have not only impressed, but have reached a level where they are earned patent certifications too. Today, we stand on the precipice of a new horizon, eager to explore how we can showcase these incredible talents on a broader stage. This morning, the initiative spearheaded by SIF brings attention to Chandrayan mission, admirably championed by Dr.G Madhavan Nair, the former ISRO chief. Launching Chandrayan was an extra source of pride for expatriate Indians too, garnering praise from the host countries, nationals, and strengthening our sense of contribution. Chandrayan 3 follows a successful landing, represents India's continued lunar exploration efforts, comprising a lander and a rover. It conducts comprehensive studies of the moon's surface, geology, and mineral composition. Equipped with advanced instruments, it seeks to expand our understanding of lunar resources and the conditions while demonstrating India's growing expertise in lunar missions. Chandrayan 3's achievement contribute a broader scientific knowledge and a potential future for lunar missions. Let's once again congratulate the team led by Dr. Sridhar Panikkar Somnath in its success of launching Chandrayan 3. As we eagerly await Dr.G Madhavan's words of wisdom and expertise, let us remember that we are in the presence of a true visionary who has helped propel our nation to the foremost of space exploration. Without further ado, let's welcome Dr. G Madhavan Nair for what promises to be an enlightening and inspiring address. There is a small request to the audience. Kindly forward your questions to the host and the designated question and answer representative who will present them on your behalf during the question and answer session. And now we hand over the session to Dr. G Madhavan Nair. Sir.
Thank you very much. Thank you for the warm welcome. My dear friends from the SIF family in the Gulf region. In fact, I'm really impressed by the activities of SIF. In the early stages of formation, I had opportunity to physically come over there and meet with several of your colleagues and have the programs initiated in the region. Certainly, it's a very noble thing to happen. The science and technology is the real mainstay for the modern civilization. And whatever we have achieved today and the conveniences what we are enjoying in the modern life is a result of the science and technology. So it's important that we nurture the activities in the science and technology field and attract the youth population towards pursuing a career in science and technology. So this is very important to sustain the human civilization in its present form and to take it to greater heights of achievements in the coming days, especially to face the problems associated with the climate change and the large population growth and the shortage of food, etc. So there are several problems to be tackled globally, and certainly only the science and technology can find a solution to the problems which are there today and which will arise in the future as well. So it is very important that the youth population takes up this role and pursue this in a great vigor in the days to come. Certainly the schools and colleges are doing their job, but beyond that, to give a backdrop of what we had in the ancient civilization, especially in the Indian continent, that was the Vedic time, we had the flourishing scientific activities in this part of the globe. Perhaps we are the first in the world to invent many things new, including the metals like copper, tin, iron, and so on. And also the Ayurvedic medicine and the Ayurvedic treatment is effective and it's being practiced even today. And astrology and astronomy and all those things are really speaking volumes about the ancient wisdom, what was there in this continent. I'm not diluting what came up in the European region as well as in the Middle East, just around the beginning of the Christian era. So there again, the civilizations adopted, and quite often the knowledge from India was passed on to this region, and that was benefited by the communities there. But they built upon that. And of course, Europe can take pride. During the Industrial Revolution, they have leapfrogged in science and technology. But in India, we have not pursued that much, especially under the foreign oppression and under the slavery which undergone for thousands of years. And once India has become independent, we have sprung back to action. And what we have seen today is a result of the achievements of the modern India in the scientific world. The flagship of that is the space research in the country. You have all watched, I'm sure that you would have definitely watched the soft landing of our Chandrayan on the lunar surface over the live telecast. Certainly, that's a great event which was observed globally, appreciated, and recognized by almost all nations in the world. And it has become a major milestone for the humanity. It is not only for the Space Research Organization, not only for India, but also for the whole world. Our Prime Minister Modi ji has really highlighted this during his BRIC meeting, which was happening in the South Africa. And as soon as the meeting was over, he landed in Bangalore to congratulate the scientists. And not only that, of course, at the time of the event, he has addressed the scientists over the web network, and he has congratulated and appreciated the efforts put in by the Indian Space Research Organization. This mission, Chandrayan-3, is very unique in many respects. As I mentioned earlier, we were able to land on the South Pole region of the moon for the first time in the world. There are other countries have gone to the moon, explored the moon, especially USA and Russia had now conducted a number of missions way back in 60s. But their concentration was essentially in the equatorial region where the conditions are favorable. But where we have attempted to go is the totally unexplored southern polar region, where only for 14 days there is sunlight. Another 14 days it is almost like night condition. There is no sunlight, and also it is almost like an emergent state. Practically nothing is disturbed there. When the moon was formed, there were certain conditions there, and more or less same thing is retained in the polar region. That's one of the interests with which people have now started going towards the South Pole mainly, because essentially a lot of water has been found in the South Polar region. Of course, just before our going, there was the mission from Russia. They wanted to have a soft landing in the southern region, but again, unfortunately, due to some technical snag, the last phase of the landing operation did not take place properly, and the spacecraft crashed landed on the lunar surface. Within a week or so, we were there, and we did the soft landing. Well, to look back, it is in the in the beginning of the first half of the about 2005, around 2005, it is the beginning of the lunar exploration program. Until then, our most of the concentration has been to look at the planet Earth, understand it better, and also use that knowledge for the benefit of the people in the country, and also provide various communication means and so on. On completion of that, we naturally ask the question, what next? Then the logical answer is to explore the nearby objects, the moon, Mars, Venus, and so on. So to exploring the planetary system in the solar system is important to understand the origin of the Earth, origin of the universe, and some of the fundamental knowledge related to the formation during the Big Bang and so on. So from that point of view, we have made a proposal to the government. Then our other Bihari Vajpayee ji was the Prime Minister, and he has gladly accepted that program. And he only has given the name Chandrayan to this mission. And in fact, he has initiated the program. But of course, as you know, that later there was a change in the government. And it was during Manmohan Ji's time that the first the moon mission took place. And we have launched from India using the Polar Satellite Launch Vehicle, the Chandrayan-1 spacecraft to the moon. And in fact, there again, we are able to show that we can go to the moon and orbit the spacecraft. And that mission, in the first attempt itself, it became a success story. Most of the other countries, they had large number of failures. Out of the 50 or 60 missions which we launched, more than 60% have been failures in the past. So in the backdrop, what India has achieved at the time was really remarkable. It's just not only going to the moon and trying to explore the surface features, but also to place the Indian flag was a big challenge. Dr. APJ Abdul Kalam was the Rashtrapati ji at the time, and he has suggested to me that you are going all the way to moon, so why don't you deposit the flag on the surface of the moon? I told him that landing on the moon is a difficult technology and we don't have the capability. And not only that, PSLV cannot carry such a heavy spacecraft all the way. So then we were just brooding on that. And soon our youngsters came out with some idea that we should make what is called a moon impact probe. That is, when the Chandrayan is going around the moon, have a small instrumental package on which our Indian flag will be printed, and that old module will be dropped from the spacecraft to the moon. Of course, when it is dropping, it falls with a very high velocity, and on impact, it will break up. But from the orbit until the landing point, it will collect scientific information and send it to us. And finally, even if it breaks up, every face of that module has got the flag imprinted on that. So our flag was virtually placed on the surface of the moon first time in 2008, November 14th, the birth anniversary of the Jawaharlal Nehru ji. So aptly, that spot was called as a Jawahar Sthal at the time. At the time itself, we had the idea when we make this observation, it has to be confirmed through collecting samples and verifying that. Of course, the fallout from the Chandrayan-1 mission was really fantastic. First time we were able to produce high resolution maps of the entire lunar surface to great precision. Earlier, the pictures available were requires maybe about 100-meter resolution is what is achieved. But we had mapped it to 10-meter resolution. We could identify each and every crater, every mountain, and also the type of irregularities and the type of even there are some imprint of some flow pattern and so on. So all these could be captured. But the most important thing was to confirm the presence of water in the lunar surface for the first time. In fact, though there were several other missions by Russia and America, but we were the first to announce that there is water on the surface of the moon. So this has been a great achievement universally, and this is well recognized. So naturally, the next is the Chandrayan 2, where we wanted to have a similar mission, at the same time, collect some samples from the surface of the moon, do the analysis and send back. This mission was attempted in 2019. Everything went off well. But unfortunately, in the last instance, about 2 kilometers above the surface of the moon, the module lost control and it crash landed on the surface. So the crash landing, it broke up, and the mission of collecting the samples and analyzing was not completed. Whereas the orbiter, which is similar to what the Chandrayan 1, is still functioning, and that is sending a lot of data. Even today, that is used as a relay station for the Chandrayan 3 mission. That is when the lander is reached the surface of the moon, the signal from that is captured by the orbiter of the Chandrayan 2, and that is relayed back to the ground. So that is still action. So naturally, we wanted to prove that we can perfect the landing technology, the soft landing on another planet. That is a very, very difficult technology, and that is what is undertaken in the Chandrayan 3. The reasons for failure could not be precisely pinpointed in the Chandrayan 2, but there is an approximate idea about what could have gone wrong, and all those elements have been strengthened by design modifications and also carrying out a large number of simulation tests of the landing operation and so on. And with that confidence only, the Chandrayan 3 was launched. Certainly, the confidence level was very high, and we were proud to say that we have every instant, right from takeoff from Sriharikota until the touchdown was telecast, and it was globally visible to the entire community all over the world. So this has been, again, a first of its kind. The final phase of landing, since we had encountered failure, we were really anxious. And in fact, Chairman Somnath has defined as a 30 minutes of horror, so to say. And it is hundreds of operations have to take place within the 30 minutes before it can make the soft landing. So this, when it is moving around the moon, it travels with a speed of about 1.6 kilometers per second. That is almost about 10 times the speed of an aircraft. So from there, it has to be brought to a soft condition. It is almost like placing a baby on a cradle. To that level of speed or the stillness has been brought in before it can be placed on the surface. So this operation was carried out, and the spacecraft very slowly descended. And in the final phase, when it is about 100 meters above the surface, its camera started looking for a clean spot where it can touch down. Of course, there is on the surface, there will be a lot of rocks and a lot of holes. And if you touch any of them, the whole mission will get to failure. So this identifying a spot was conducted within a few seconds. And once after identifying the location, the craft was slowly moved to that location and very precisely positioned on the surface of the moon. So this has been a very, very unique achievement. It was a 100% perfect touchdown, and which nobody could have done. In fact, normally aircrafts and all, they depend on beacons in the airfield, the GPS and other systems as navigation aids to make a landing in even a normal airstrip. In a cloudy condition, sometimes they may abort the touchdown also. But imagine that we have to at a 400,000 kilometers away on an unknown place, uncharted territory, no beacons, no guidance, nothing is available. Autonomously, the landing has to take place. So this is a next to impossible mission. The ISRO scientists and others have done precisely what is needed, and the mission has been 100% success at the time. After landing there, the rover, it's a small wheeled vehicle which rolls out of the lander, and it has got a set of instruments. It can move around very slowly, of course, a few centimeters per minute. And finally, within the 14 days of a lifetime, it has traveled over 100 meters around the landing spot. It has collected several samples from the moon surface, and it was analyzed using various techniques like laser spectrometry and the chemical analysis, and also the temperature monitoring and so on. And these data has been collected and sent back to us. So this confirms whatever we had observed in the remote observation is accurate and correct. The data which has been obtained has been revalidated, and that way I read that whatever the mission, what we have started nearly 20 years back in 2005, has really reached this pinnacle of success, and that is what has demonstrated to the world through the Chandrayan 3. Of course, this is really proving the technology to the highest level of perfection in this very sophisticated field of space research, and perhaps we have become one of the global leaders in this area. Comparable strength has got only for the USA, Russia, and China, and all of them have got a similar technology and similar missions. But we are unique to go to the South Pole for the first time and make it a success. And also the findings on this is going to be used by the scientists in India to start with, and later by the global community for various research purposes, and confirming looking at the origin of the planet Earth and the initial conditions of the moon and so on. So that way, it's a very unique mission, and we are happy that this has ended up very successfully. Now, of course, you know that in the immediate future, there is another mission planned to observe the sun. As you know, the sun is the major source of energy and sustaining all life and all the conditions on the earth. So understanding the phenomena, the sun itself integrated depth, is very, very important. From the ground, if you start observing, it is marred by the atmosphere, the haze, the rain, and the dust particles, and so on. So we had to observe from outside the atmosphere. Of course, we can have a spacecraft which can go around Earth and then look at the sun, but it will not be a continuous observation. It's only in maybe once in an hour or so. So we selected a point somewhere, I will not say midway, very far away from here, but which can have a undisturbed or clear view of the sun, 24/7 basis. That is called a Lagrangian point. That is the point where the Earth's gravity and the sun's gravity almost equals, and they cancel each other. So the spacecraft can be maintained there with the least energy, and that the spacecraft has been launched for. It takes about 150 days or so to travel about 15 million kilometers that far. And then after reaching there, it will start its observation of the solar phenomena and send back to ground. Then, of course, there is another immediate mission to look at the Venus. It has got a dense atmosphere and a very high temperatures in the Venus. Mars, of course, we have gone earlier, but it will be followed with subsequent missions for a detailed study in the coming years as well. But more important than all these is to have the human spaceflight capability. India has launched a program a few years back, what is called a Gaganyaan, where a capsule is being designed, which will be carried by the GSLV Mark III vehicle, which will go around Earth for about a week or so. The astronauts will be able to stay in the space for about a week and then later bring them safely back to ground. The design of all these have been completed and the development work is halfway through. Maybe within a couple of years, we will see that our astronauts will be flying in our own capsule to space and coming back to ground. So that is only a beginning of what we can look forward to as a planetary travel in the days to come. Well, that way, again, India want to show to the world that we are not lagging behind in space technology in any respects. In fact, this is one of the flagship programs that the government is supporting fully. And the ISRO is one of the teams, performing teams, and perhaps one of the best organization in the country who are able to do almost all these activities on a shoestring budget. So in fact, they have shown to the world how cost effectively such programs can be managed and the benefits can be brought on an immediate basis to the common man in the country. So that way, the Chandrayan mission has been really showcasing our technology, especially in the time of G20. This mission success has been appreciated by the world leaders who visited in New Delhi for the sessions. And perhaps India's prestige has gone under manyfold in the eyes of the whole world. So that is perhaps another spin-off benefit. Again, ISRO was kind enough to take a large number of students to watch the launch of the Chandrayan-3 from the Sriharikota Island and also to participate in the final touchdown operations and so on. So the enthusiasm of the youth community towards the science has really been enhanced by this Chandrayan mission as well. So that way, there's a lot of spin-off benefits have come out of it. And we are really happy that we were able to be one of the pioneers in this field. Thank you. I will face the questions if you have any. Thank you.
Namaste, Dr.G Madhavan Nair, sir. A very good morning to you. It is such a pleasure to have you amongst us. We are all thrilled and overwhelmed at the same time. As a part of our schedule, some of our enthusiastic inquirers and learners would be utilizing this golden opportunity to interact with you by asking their questions. So I would request you to kindly enlighten them, not only to them, to us also, by answering those questions. So we begin with the winners of National Children's Science Congress and Shastra Pratibha winners, followed by the students from various.
Anupama,
Ma'am,
I think
Anupama ma'am, your voice is not clear. Anupama ma'am,
Yes.
your voice is not clear. Just look towards the camera and speak, please.
All right.
Yeah, much clearer.
Should I start from the beginning?
Yes, ma'am.
Namaste, Dr.G Madhavan Nair, sir. A very good morning to you. It's such a pleasure to have you amongst us. We are all thrilled and overwhelmed at the same time. As a part of our schedule, some of our enthusiastic inquirers and learners would be utilizing this golden opportunity to interact with you by asking their questions. I would request you to kindly enlighten not only our budding scientists, but also all of us by answering these questions. So we begin with the winners of National Children's Science Congress and Shastra Pratibha, which will be subsequently followed by the students from various schools. So first we have Ridan from Al Khuzama International School, Dammam. Ridan.
Radhan, you may ask your question now. No, Hridan. Where is Hridan?
Yes.
Hridan?
Okay, so first of all, I would like to give me such an opportunity to interact with such an experienced scientist like you. ISRO's remarkable achievements in space exploration are well known, but what makes us all wonder is how they accomplished it. Could you tell me about the upgrades in Chandrayan 3 that reduced failure probability to almost zero in comparison to Chandrayan 2?
Can you repeat the last portion? I didn't get it properly. Can you repeat the last part of your question?
Could you tell me about the upgrades in Chandrayan 3 that reduced failure probability to almost zero in comparison to Chandrayan 2?
Well, I think the basic mission objective was same, but in Chandrayaan 2, the last minute something went wrong during the descent operation, and they have really made design changes in the landing sequence. The instruments used for observation, like camera and the laser ranging system, the thrusters used for control, and so on. And a large number of simulations of those landing operations have been done on the ground before we cleared for the flight. In fact, that's a reason that we were able to really go there and land there perfectly without any defect. The lessons what we have learned from the Chandrayaan 2 has really become a driving force for implementing the corrective actions in the hardware and the software required for the landing.
Next, thank you, Ridan, for your question. Now we have question number 2, which will be asked by Janvi Ramesh from New Middle East International School, Riyadh. Janvi, over to you.
Good afternoon, sir. It is my privilege to be speaking to you. I wanted to ask, what are the main challenges and opportunities that you see ISRO facing in the future when it comes to future lunar exploration and missions and space endeavors?
Well, certainly what we have made only is a small beginning, but we had to go a long way. We know that there are precious minerals available on the lunar surface, especially the helium-3, which is available only on the moon. It is emitted from the sun, but it does not penetrate through the atmosphere and reach the Earth. So, but at the same time, since there is no atmosphere on the moon, it is deposited on the lunar surface. But the importance of helium-3 is that it is the ideal fuel for the fusion reaction. As you know, a small quantity of helium-3 is sufficient to run a power plant for years together. So this fuel, if it is brought here, it can bring a lot of relief to our pressure on the fuel availability, especially is highly, it does not have any dangers associated with radiation or pollution, and is a clean fuel. So whether we can excavate this helium-3 from there and bring here is the next challenge. Then perhaps establishing a observatory on the moon so that you can have a continuous watch of the stellar system, the galaxies and beyond become unique. But ultimately, can we have the human flights to space and human colonies? That's the big question before us. But one has to make a lot of studies and efforts on that. So one has to really think of how best we can make use of this nearby object, our friendly objects, the moon, for the benefit of the mankind on the Earth. And what type of technologies are required for bringing back the resources from the moon to Earth will become the biggest challenge.
Janvi, thank you for your question. The next question is from Aban Ishtiaq from Modern Middle East International School, Riyadh. Aban, over to you. You may unmute yourself, Aban. Yeah.
Good morning, sir. My name is Aban Ishtiaq from Modern Middle East International School, Riyadh. My question is, what is the impact of Chandrayan 3's success on common man?
Well, as I mentioned to you, it is first of all showcasing the Indian technology in the world. As a nation, every Indian is proud of that. Second, immediate benefit, I will not say there is an immediate direct benefit, but long-term benefit is possible if we can exploit resources like helium-3 from moon and bring back to Earth. So it is an investment for the future. But of course, this is understanding the origin of the Earth, how it has progressed over the last 4.5 billion years. And that can be throw a lot of ideas and inputs for analyzing what is going to happen for the future, especially related to the climate change studies and other things. We are going to get a lot of innovative ideas out of these missions. So that will have a long-term effect only. So it is basically an investment for the future, what is done through the Chandrayan 3.
Okay, thank you, sir.
Thank you, Aban. The next question is from Sausan Jilani from International Indian School, Jeddah, Western Region.
Very good morning, sir. So I can't believe I'm actually speaking to you. Thank you. My question is, we believe that hydrogen and oxygen are like the basic fuel for a rocket. And now that Chandrayan 3 has noticed ice, which is H2O, on the moon, would it be logical to set up the next deep space program from the moon only? And for such a program, like the scientist movement will be very frequent, which means we need a powerful and economical rocket that can reach the moon within a couple of days. So is there a plan for this?
Certainly, I think it is a very good opportunity. As you know, reaching the moon itself, we need a large rockets. But if it has to carry the fuel for further travel to Mars or to the other regions of the solar system, you require fuel. Certainly, the water which is available there on the lunar surface is a very unique finding. That is very important. Of course, you can dissociate, get the oxygen for the life sustenance. And the hydrogen and oxygen, if it burn together, it becomes fuel for the long distance travel as well. So certainly that is one of the ideas being pursued by the scientific community. And probably when the moon becomes a springboard for the planetary exploration, the water is going to really help the scientific community.
Thank you. The next question is from Prashantini from New Middle East International School, Riyadh. Prashantini, over to you.
Thank you, ma'am. Hello, sir. I am Prashantini Sundar, and I'm truly, truly privileged to be getting this opportunity. Ever since I was a kid, I have been truly inspired by the great ISRO scientists, and you are one of my greatest inspirations, sir. I hope to pursue a career in astronomy, and this is just a wonderful opportunity for me. So my question is that I have read that the Chandrayan's lander and rover mission only lasted for 14 days, which is the length of the lunar day, because the nighttime conditions were too extreme. So how could we go about designing a vehicle that could withstand these extreme nighttime conditions?
Well, as I told earlier, we have selected a region where the sunlight is available only for 14 days, the lunar daytime. And the entire system on the lander as well as rover is based on the electric power. There are batteries which has to be charged using the sunlight. The solar panels are there in both the lander as well as rover. So as long as they are illuminated, the charging process will take place. But during the dark period, there is no charging of these batteries, and so we cannot operate them. That's the first part of it. The second part is, of course, when the sunlight is not falling in the region, the ambient temperatures go down very low values. The estimated value is around minus 150 degrees to minus 200 degrees Celsius. So at that temperature, how the systems will function, we were keeping our fingers crossed. The batteries, the electrolyte can get dried up completely, and perhaps some of the capacitors and even the electronic components, the mechanical parts can get jammed and so on. So that way, I think, but we were hoping when the sunlight comes back again, it will heat up, it will warm up and again re-energize. But unfortunately, so far, about almost a week has passed now, it has not woken up, and the chances of it survival is remote. But if you want to overcome this problem, we should have a continuous power source on board. So for that, there's only way is to go in for a nuclear power source. If you have a nuclear power source that can provide the heating, so that can keep the entire system warm, and also provide the energy for its operation. So maybe the future missions, when you are planning in that region, the nuclear power source become important. And also perhaps even after going there, initially having this solar system and dissociate water, and that store the oxygen and hydrogen, which can be burnt as a fuel and so on. So there are several options possible. One has to make a study of these things and plan for the future measures.
Okay, sir. So if we did manage to overcome these and actually get a vehicle that could last during the lunar nighttime also, are there any extra measurements that we would be able to get that we didn't get this time?
Certainly, the lunar nighttime observations are very, very important, because we don't know even the temperature conditions there. At low temperatures, how the things behave there, and whether any other phenomena is there, etc. One has to understand. So maybe, in fact, the Russian mission had the nuclear power supply on board, but unfortunately, they didn't succeed in landing there. But maybe for our future missions, we may adopt such a scheme so that we will be able to collect data.
Okay, sir. Thank you so much, sir.
Thank you, Prashantini. I have an announcement to make. If anybody is interested to ask any questions, you are supposed to send the questions to the host. We will be taking the questions up till 11. Okay, so the next question will be asked by Giovanna Jerome from Indian International School, Riyadh. Over to you, Giovanna.
Good morning, sir. I'm Joanna Jerome from International Indian School, Riyadh. Nice to meet you, sir. And my question is, what is the impact of Chandrayan-3's success on ISRO's future manned space missions?
Well, there are two independent missions. The common element is the launch vehicle use the same. The GSLV Mark III is the one which is going to be used for the which has been used for the lunar mission, and the same will be used for the next the Gaganyaan mission as well. So that way, whatever the performance what we have demonstrated in the GSLV Mark III flight, it gives us the confidence for the next flight with the humans on board as well. But other than that, there is no common link. The Gaganyaan project is a very very massive effort required in preparing a capsule with the life support system, the food supplies, the waste management, and the radiation protection, and so on, which can sustain the human beings in a very favorable conditions in the outer space. So that module design is the most challenging task before us. And in fact, the design is going on. And not only that, when the launching of this takes place, if any untoward incident is there with the launch phase, how to jettison the capsule and save the people in the capsule, that also becomes important. But more challenging than that is the re-entry from the outer space to the atmosphere, and then capturing it back on the ground. So these things have to be perfected. First, of course, we will be doing a lot of simulations, tests on the ground, and then they will be sending capsule with the dummy modules instead of the human beings. And then after that, the human flight will start. So these operations are going on parallelly.
Thank you, sir.
Thank you, Giovanna. So now I would be taking the questions from the students, and they have posted the questions to us, and I would be asking the questions on their behalf. So the first question is by Hania Maheen. She's from International Indian School, Dammam. Will we send another Chandrayan? If so, what will be its mission?
Well, as I mentioned earlier, the next attempt will be whether we can collect samples and bring back to Earth. So that is going to be a real challenging one. And maybe 4 or 5 years from now, we may be attempting that. Parallelly, the studies for an observatory on the moon will be on, and maybe within 10 years, we should be able to establish a instrumented laboratory there, which will observe not only moon, but also the planetary system and the stellar systems and so on. So this mission could be there by about 2010. And of course, we have signed an agreement with USA for carrying an astronaut in their mission to moon. So one of our Indian astronauts will be flying along with the Americans to the moon in their mission, maybe within the next few years' time. So these are some of the lunar exploration program which are on the anvil.
Thank you, sir. The next question is from Abdul Rahman Muhammad. The child is from International Indian School, Dammam. His question is shooting a rocket straight up the best way to send a rocket to space, or is there a better way?
Well, today, with whatever knowledge we have, using a rocket is the easiest and cost-effective way of reaching to space. You know, we have to climb a distance of nearly a few hundred kilometers and also impart a velocity of nearly 7 kilometers per second if the spacecraft is to stay in Earth's orbit, and maybe around 11.5 kilometers per second to break away from the Earth and go to the other planets in the solar system. So that way, the rocket, multi-stage rocket are the most effective ones which can be used at the moment. But there were earlier studies conducted whether you can use a huge cannon and so on, or can we take a rocket in an aircraft launch and so on. These studies have shown that they are complicated, and also they are not cannot carry such heavy spacecraft to orbit. So today the rockets become the mainstay for such purposes.
Thank you, sir. The next question is from Gibran Ishtiaq. The child is from Modern Middle East International School, Riyadh. What is next after Chandrayaan 3?
Well, I mentioned in my earlier my introductory remark itself. One is observing the sun. The Aditya 1 mission is already on. It is on the way to the Lagrangian point. It will reach there in about 100 days from now and start observing the solar system. Then the planet to Venus, the mission to Venus also is being designed. Of course, the human spaceflight program is the next flagship program for India.
So there's a little girl from grade 4, Madhurima Subhash. She's from New Middle East International School. She wants to know 3 things from you, sir. Can you share your childhood memories, sir? This is the first question. And second one is, who is your role model and source of inspiration? And the third question she has asked is, what message you would wish to convey to the younger generation?
Well, I think recalling my childhood days, I think it was a very, very different world altogether. In fact, so there is no modern means of communication. There is no television. There is no telephone. The most sophisticated device which I have come across as a child is the bulla cart. So from there, today you can see how the world has progressed, how the science and technology has progressed and so on. I have really grown up in independent India, observing the development of science and technology, how it has penetrated and reached every nook and corner of India. So that's a contrast which comes to my mind when I think of my childhood. Now, as far as my role model is concerned, I will say that my role model was Dr. Vikram Sarabhai, but at the same time, my guru, from whom I have learned all my technology management and also the developmental skills, is Dr. APJ Abdul Kalam, who was our former president. So these were the two people who I owe all my achievements in my career, and they have really guided us to reach this stage. Now, as far as the youngsters are concerned, I think it's very difficult to advise because I'm pretty out of tune with the modern world and modern technology. But one common factor is that as a student, you should have a scientific temper. The scientific temper means it is not just studying mathematics, physics, chemistry, or biology. Of course, those studies are important. They are the fundamentals which one should know if you want to pursue the scientific research or the technology. But more than that, the scientific temper means you observe what is happening around. You try to understand those phenomena, try to analyze how and why of it, why it is happening and how it is happening. And there are so many questions unanswered. Try to look for answers to the unanswered questions. So keep your eyes and ears open so that your learning process continues and you have an analytical mind to analyze and practice. And beyond that, whatever knowledge you acquire should be utilized for the benefit of the people, for yourself and the people around you. Then only you can become a success. It's not only the acquisition of knowledge, but practicing it for implementing practical projects are very, very important, and one should pursue that.
Yes.
Thank you.
The next question is from Shivani Shelvi, who's from Indian International School, Dammam. Her question is, why did ISRO scientists decide to land on the south pole of the moon?
Well, I mentioned earlier, we have not explored the region no country has seen very closely the region, and it is almost in the virgin condition as when the moon was formed. Again, the presence of water is more in the polar region, and that's the reason that understanding the polar region is more important for the future mission, trying to get the conditions which is prevalent there, and those conditions can be utilized for design of our future craft as well as the exploratory laboratories which you want to establish there.
The next question is from Roichan KJ. Unfortunately, her school name is not mentioned. How will astronauts be selected for future mission of ISRO?
Well, for the time being, the selection was from among the fighter pilots who were physically capable of doing that and who have got demonstrated their capability in flying the high-speed aircraft have been selected. And they have undergone training in the facilities in Russia, and they are standing by. Of course, initially for the developmental flights, this may continue. Once the systems are developed and proven, we may be able to carry the ordinary people also, mainly the scientists who want to conduct the scientific experiments in space, could be conditioned to become astronauts and carried on board. And that has to go through, first of all, their scientific interest and their physical condition as well.
Another question from Prashantini, New Middle East International School. What to study to pursue a career in ISRO? And second question, how dangerous is the mission to Venus and how far is the future, in the future is this mission?
Well, if ISRO works on rocket technology, the spacecraft technology, and also the space sciences. So if you have got a good background in any of the sciences or in engineering, that is sufficient and one can get into ISRO. But of course, there is another way. After completing the +2, you can, if you seek admission to the Space Science and Technology Institute at Thiruvananthapuram, They take bright youngsters who have good score in JEE, and they are trained on the aerospace subjects and absorbed in the ISRO stream directly. So these are the two routes by which you can go. After graduation in the engineering, after post-graduation in the science, you can appear for the again entrance test and the interviews before we can join ISRO.
There's one question from Shalini, who is from New Middle East International School, Riyadh. What kind of tests are usually conducted on the lander and rover to decrease the chances of disruptions to the mission? Are they tested in a computer simulation of moon surface or in a physical artificial environment?
Well, a rover was being tested on simulated conditions here, because the models of Chandrayan, the pictures taken from there, almost similar features were created on the ground, and the rover was made to move through that. Then, of course, these instruments are subjected to what is called a thermovacuum test. In a huge chamber, you put these instruments and simulate to the solar radiation and other conditions which are encountered during the flight and during the landing, etc. Then most of the simulations are done digitally in computer, especially the landing sequence. The sensors, so data has been fed to the computer, and the computer will command the thrusters, and the thrust outputs will be converted into the 6 degrees of motion, and from there you try to get the final results and so on. So a virtual simulation package has been created in the computer, and there one can not only simulate the nominal landing operation, but also off-nominal landing operation. And a large number of such simulations have been carried out before getting confidence for flying the system. So this is a normal process. Whether it's in the rockets or the spacecraft missions, we will do a computer-based simulation of the events to confirm the satisfactory performance of the subsystems.
Arna Shah from International Indian School, Dammam wants to know, did Chandrayaan-3 mission help the Aditya L1 mission in any way?
No, there were programs running parallelly. So the spacecraft was almost built by the time the Chandrayaan landing has taken place. And there is no commonality between these two.
Nainika Vinod from Middle East International School wants to know, how many more years would it take for human space travel to the moon be possible?
Well, I think I can only stretch whatever possible with our imagination. But the first thing is we have huge funding for that. But with about 10 years time frame, such human space flight to the moon by Indians is possible. But of course, already US is preparing for their travel to moon, and already a dummy flight has taken place, and actual live humans will travel within a year or two by US.
The next question is it's from Madhav S. Nair from IIS Dammam. Were there any disadvantages of Chandrayaan-3 before the launch, and how did ISRO solve them?
Well, I think they were carefully planned operations. So entire sequence right from the beginning of the rocket launch to the end has gone very precisely as per the plan. So this shows that if you carefully think of all possibilities and plan your mission, it can be done on schedule. And again, based on the computer simulations, and those simulation results have been proven correct during the Chandrayaan-3 mission.
Fatima Rida from Indian International School, Dammam wants to know, was it impossible to design a circuit and hardware that could sustain the harsh weather, -200 and below, during lunar night?
Well, theoretically, it is possible to do the design. But there are certain things which, the physical phenomena which we cannot stop. There are many materials that lose their properties at the negative temperatures, especially after about minus 60 degrees or so. Most of the materials lose their mechanical strength. Again, the chemical properties of some of the electrolytes and other things used in the capacitors, batteries, and other things, they behave differently at the temperatures. They become a gel or they become a solids at the time, and they can apply extra pressure on the system and lead to a breakup. More than that, the dissimilar materials, if we are used, it can lead to mechanical jamming of moving parts and so on. So there are a host of problems to be solved if we want to make it work at negative temperatures. Of course, on the ground, we have the systems working at minus 250 degrees. That is about hydrogen temperature in the cryogenic engine. But they are all very specially designed for that limited operation and for limited duration.
ABL Saju, International Indian School, Dammam, wants to know, how is the rocket assembled as it separates in space?
Well, I think normally there's what is called a separation mechanism. They will be operated using explosives. First, for severing the connection between the forward stage and the spin stage. And there are small rockets used to give reverse velocity to the spin stage so that it can move away from the forward moving object. So there's a mechanism which normally employed in our rockets.
There's a child with the name Jesse wants to know, which thing from APJ Abdul Kalam sir inspired you that you got so attracted and attached to his way of work and he became your role model?
Well, he was a finest human being with a very open heart and inquisitive mind and courageous in making decisions. So there are several properties of that. In fact, I have highlighted some of this in my autobiography, which is available now. It's called the Rocketing Through the Skies, a book published recently, an autobiography. I have described elaborately my experience with Dr. Kalam in that.
Ridan Patel from Al Khuzama International School wants to know, were there any automations during the landing of Vikram lander?
Yes, the entire process is automated. There's actually a computer which controls the operation for the last 30 minutes. It is programmed to carry out the functions in a particular manner, and the real-time corrections are implemented based on the data received from the stereoscopic camera, laser ranging systems, and so on. And that is providing the inputs, and that generates the corrective command so that the lander follows a predetermined path to arrive at the lunar surface. So it is a totally an automated onboard process which is implemented.
Then there's a question from Ayan Anwar. Why hasn't nuclear energy been used in lunar night missions yet? I have another question. Could there be a...
Well, as far as the nuclear power source is concerned, development is very complex. First of all, we have to handle the plutonium, which is a hazardous radiation. Hazards are plenty, and using that to create a power source, etc., is a real challenging job. It is as good as creating a mini nuclear reactor, which can be carried on a rocket. So it has got a lot of safety concerns associated with that, and one has to decipher those things. We have not thought about this process yet. So it will take a little bit time before we can decipher this. And basic technology and understanding is available with Atomic Energy Department and the Space Department and Atomic Energy Department working together. We'll be able to realize such missions for the future.
There's a question from Anand Padmanabhan. Is there any research going to reduce pollution due to rocket launching? Is it possible to use electricity to launch a rocket in future?
Well, I think as far as the pollution aspect is concerned, it is not very high because after all, we are burning only a few hundred tons of propellant, whereas the carbon emission runs into millions of tons per day. So compared to that, is very minuscule. But at the same time, ISRO is working on future rocket system, especially the hydrogen and oxygen rockets. They don't pollute. The output only is the water vapor form. And similarly, if you use a semi-cryogenic engine using either methane or natural gas and oxygen, again, pollution will be minimal. So that type of huge power plants are being designed. Nuclear power plants, yes, the electric power propulsion is possible, but for the initial liftoff, etc., you require large thrusts, and it is not feasible to realize using the electric propulsion at this moment. So for interplanetary travel, the electric propulsion can be used, and there are some development activities being carried out by ISRO in the electrical propulsion field as well. But for the getting off from the ground, you require still a chemical propulsion.
There's a question, impact of SpaceX type rockets, which can come back to its original launch pad. It's from Vaishnavi, International Indian School, Dammam.
Well,
He wants to know. Yes, sir. Please carry on, sir.
Well, this rocket development by America is very unique. Elon Musk has harnessed technology from various parts of the world, and he has designed a unique rocket which can be launched, and after its mission is over, it can be, again, the rocket engines can be burnt to bring it back to the launch pad. So this is a very unique development, and perhaps for the first time in the world, and he has successfully demonstrated it in the SpaceX. Certainly, it's when you bring back this rocket, it can be reconditioned and reused again. So that way, the cost of launch will come down. And this is one major achievement by the US. And there is no other country which has got a similar technology at this moment.
Aban Pasha of grade 10 from New Middle East International School wants to know if there will be any financial difficulties not able to read the question properly. 1 minute, sir. Just a moment. Would there be any financial difficulties for ISRO's next Chandrayan mission if a nuclear generator was implanted in the rover? And also, will there be any risk of implanting a nuclear power in the rover?
Well, I think it is something which is affordable, but more than the finance part of it, the safety concerns and problems associated with handling the nuclear power plant, and which has to be made in a very, very, very compact form, is something which is a big challenge. It's a technology challenge which has to solve rather than the financial problem.
There's one child who wants to know, is Moon a mega structure created by aliens?
Well, first of all, the aliens itself, is a big question mark. So it is in the fiction which people talk about it. And perhaps quite often the fiction become reality maybe tens or hundreds of years later.
There's one child, Sanjeev Madhu from International Indian School, Dammam. He wants to know, with Chandrayan's 3 success, will it be open better and more advanced futuristic opportunities, that is interplanetary bases, stations, and human settlements?
Yes, certainly. This is only the basic elements which are required for undertaking such mission has been demonstrated in this. So we really plans for a colony, perhaps in Mars. Some of these elements and lessons what we have learned from the Chandrayan will become useful.
There's one child who's asking, it's Zaid, who wants to know, why did Chandrayan 3 do multiple orbital raising maneuvers? Is it due to the Oberth effect? Most other lunar missions did the trans-lunar injection burn in one burn.
Well, certainly we have gone to a the distance between the Earth and the Moon is nearly 4 lakhs kilometers. So during this period, after it leaves the Earth's gravitational field, the influence of other planets and they become the important. So we don't have a precise idea of what this is. So going step by step, in each of these orbit tracing maneuver, we can calibrate the system. First, the disturbance of forces acting on it, and the next, the performance of the rocket engines which are being used for it. And the net result, we are able to precisely guide and orient the path towards the moon. So this is a cautious approach of going towards the moon. And that's one of the reasons that we were able to achieve 100% success in all our interplanetary missions so far.
So one repeated question is coming again and again, though you have answered that already. Chandrayan 3 is inspiring many children to pursue as a space scientist. So what would be helpful to us to become one? Many students want to know, and this question is getting repeated again and again, though you have answered. Could you just repeat the answer once more, sir?
Of course, the basic science behind is something to understand the origin of the planetary system. As you know, the moon has spun off from the Earth about 4.5 billion years back. And since there is no atmosphere, there's no winds and disturbing factors, the moon is a divergent condition as what it was originally separated from the Earth 4.5 billion years back. So to get an idea about the various elements and their conditions on the lunar surface, we'll throw some light as to how the Earth was in the past and how it evolved over years and so on. That's one of the things. Second, as I mentioned, the helium-3 availability is very important, whether we can exploit and use it for nuclear fission. Then the third aspect is about the water, which if it is confirmed and available quantities, it can be used for interplanetary travels as fuel, producing fuel out of water using the solar energy and so on. Again, establishing a observatory on the moon, some of the inputs which are required for it can be derived from such missions. So these are the primary benefits which come out of the Chandrayan 3 mission.
So there's one more question. Actually, this child's name is Muhammad Khalil. He wants to know, is the first moon landing fake or real? Actually, if I'm not wrong, sir, a few days back, even I watched a video on YouTube where it was saying that the Neil Armstrong and all, I mean, when they went for the mission, it wasn't a real thing. So I think that with that concern itself, the question has been posted here. Was it real or?
Well, I think I was just beginning my career when this moon landing operation took place. And I was lucky enough to hear the running commentary. Of course, those days the television was not proper. So it was over radio, the running commentary of the moon landing of Neil Armstrong. And that was broadcast by USA and live. And I was sort of a party to hearing that commentary. Again, our Chandrayan mission has taken some pictures where the landing site was there, and that clearly shows that footprints which was left behind long back by all the US astronauts and so on. So there is no reason to disbelieve that the people have not landed there on the moon. They have landed not only once, a few times, and collected samples and brought back as well. So the moon mission, which US has done in 60s, is real.
I think we can conclude the question answer session here, sir. It was such a pleasure to receive the answers from your end. And I am very sure that it was such an enlightening session, not only for the kids, even for us. Thank you so much, sir, for your time.
My pleasure interacting with the children. They are all well read and very intelligent questions they have been asking. Thank you.
Thank you so much, sir.
I would like to express my gratitude to Dr. Madhavan Nair for his insightful commentary during the Chandrayan launch coverage. His informative insights spanning from the initial phase of the successful culmination provided a remarkable journey down the memory lane. His expertise added depth to the experience and enriched our understanding on this historic event. Sir, I appreciate with gratitude for addressing our inquisitive minds with patience and thorough response. Acknowledging the efforts of our organization like SIF, Science India Forum, and our impactful activities is important in promoting inclusive and making positive changes in society. It's crucial to recognize and support our valuable contributions. Thank you once again, sir. Now I would request Danish Ji to propose the formal vote of thanks. Danish Ji.
Thank you, Padmini ma'am. It's really a great honor and privilege to thank Padma Bhushan and Padma Vibhushan awardee, respected and honorable Dr. G Madhavan Nair, sir. Dr. Madhavan, sir, with your presence and guidance, we are really feeling elated and really literally have a feeling of being on the surface of the moon today. Your participation in today's SIF activity and valuable interaction with all students will have a very deep-rooted and positive impact on the young Indian minds, which will help and nurture more scientists and develop a more scientific approach in the young minds of our great nation. It was really good to hear your personal interaction with your guru and our ex-president, Dr. APJ Kalam, to place the Indian flag on the moon in year 2008 at Jawahar Point. Chandrayan series is a great success story to learn from our previous failures and convert those experiences into success, and literally to make an equipment which is flying at a speed of 10 times of an aircraft to land, as Dr. Madhavan said, like a baby in a cradle. I am sure, Dr. Madhavan sir, that the coming missions of ISRO, like Aditya, which will make us unable to reach up to sun, and Navik, which is being planned to reach up to the deep bottom of the sea, will be successful under the able hands of your successors at ISRO. It's also important to understand the harsh conditions where our equipment, all gadgets, all communication tools survive from -150 degrees centigrade, which is 400,000 kilometers away remotely from Earth. Dr. Madhavan sir, it was really a pleasure to hear you interacting with our students, wherein you did mention about your childhood stories, where you had no internet, no television, possibly only a remote small-time radio availability. And coming from that background, you are part of the mission of Moon to reach as far away as 400,000 kilometers away from Earth. We must thank you, Dr. Madhavan Nair, for all of your lifetime achievements and to participate in our Science India Forum activities. Thank you, sir. For any such activity, it's also equally important that we have the support from all local schools, the managing committees, the dignitary principals, vice principal, headmasters, class teachers, and the most important link between all the students and Science India Forum organization, the coordinators of Science India Forum in each and every school. With all of your active support, it enables us to reach each and every young mind who is going to shape up the world in near future. Thank you all schools and managing committees and principals for your support, and we look forward to seek your patronage for the upcoming academic year as well. To all students, without you, these kind of programs are not at all possible. On behalf of Science India Forum team, we thank each one of you for actively participating in all SIF activities in the whole of Gulf. The young minds like you are a true inspiration actually to all of us in Science India Forum to work in our activities. Your inquisitive minds is paving the progress for humankind and our great country. I urge all of you students to keep on participating in Science India Forum activities. I thank your parents who also allowed you to attend the activity and spare your valuable time in your students' life. We are proud of you children indeed. And last but not the least, I also take the opportunity to thank the whole of Science India Forum team, our national president of Saudi Arabia and Qatar, who were the background support for this event, all official and designated team members of Science India Forum, who volunteered in arranging and organizing today's activity, regardless of their busy schedules and professional fronts. Your organizing efforts have made today's event a smooth experience for everyone and a memorable one. I appreciate your attention to each detail to make this event a great success. Thank you all once again. Namaste, and back to the host, Padmini Nair, madam, please. Thank you.
Thank you, Danishji. In conclusion, let's remember that the torch of knowledge knows no borders